My dear students, so I am your Arka sir. So I have come with a fresh and new episode in my channel Physics Scholar. Okay, and JEE NEET special, and my topic is current electricity. Okay, DC current and electricity. So already I have uploaded some videos and on this topic. So more MCQ problems we will solve. As much as we will solve, okay, you will be very much confident to solve it in the examination hall. So the practice is required, because practice makes you perfect. Now the thing is that, and also confident. Now the thing is that there are so many MCQ, so I will select the probable questions that actually used to come frequently in JEE and NEET, that type of sums. Okay, so if you can solve all whatever I will upload topic wise, 100% will get benefit from it. Okay. So now let us start the today's topic. So basically it based on the Kirchhoff's current law and voltage law. What is the Kirchhoff's current law? The current entering, the algebraic sum of the current entering in a particular junction of an electrical circuit is 0. The current which is entering towards the junction will be positive and coming out from the junction will be negative. And algebraic sum of all the positive and negative currents will be 0. Clear? And the KVL means what? The algebraic sum of the product of the algebraic sum of all the voltage, clear, inside a closed loop will always be 0. Clear? Now the thing is that here what current of 6 ampere enters, current of 6 ampere. So this is the current of 6 amperes enters in a circuit which is the equilateral triangle. That means three sides are equal in length. Okay, PQR. Okay, so now 3 wires are there, and each of the wire have resistance what 2 ohms. Clear? And it is what connected, and one corner through R. Okay, the current is going out. Clear? Now the value of I1, I2 will be, so 4 options are given: 2 ampere, 4 ampere, 4 2, 1 2, 2 3. Clear? Now see here, this is the junction. Okay, this is the junction of the circuit. This is the junction of the circuit. So here you see 6 ampere current is entering, and I2 and I1 and I2 are coming. Okay, these two currents are leaving from the junction. Okay, from this point, and 6 ampere is entering. Now what will happen then? 6 will be what? 6 will be positive and I1, I2 will be negative. That means what? It will be 6 minus I1 minus I2 is equal to 0. The algebraic sums of the current at this junction, applying, okay, KCL at junction P. Okay, applying KCL. Clear? KCL, what? It will be what? 6 minus I1 minus I2 is equal to 0. So from there what we have written, 6 is equal to I1 plus I2. Clear? So I1 plus I2 is equal to 6. Now this is the closed loop. See, this is a circle, a triangle. This is the closed loop. So what is the closed loop? P, Q, R, P. So applying KVL in P, Q, R, P loop. Clear? So here, okay, so here what this is what clockwise, anti-clockwise, and this is what clockwise. Clear? So it is anti-clockwise, that's why it is what? Minus 2 I1. Clear? Anti-clockwise. Okay, minus 2 I1. Then here also the I1 will flow. What? It is also what? Anti-clockwise, that's why minus 2 I1. Clear? Here it is flowing to clockwise. What? That's why plus 2 I2 is equal to 0. Okay, you have understood why it is minus and why it is plus. So it is what? Minus 2 I1 minus 2 I1 minus 4 I1. Okay, minus 2 I2 is equal to 0. Clear? So we can also write here 2 I1 minus I2 is equal to 0. So it is equation number 2. So equation number 1 and 2. Clear? So 1 plus 2 we get what? 2 I1 minus 1 is I1 plus I2 is equal to 6, and it is 2 I1 minus I2 is equal to 0. Clear? So this will be cancelled. So 3 I1 is equal to 6. So I1 is equal to 3. Clear? So from equation 1 we get equation 1 we get what? I1 plus I2 is equal to 6. I1 plus I2 is equal to 6. So value of I1 is given 3. So 3 plus I2 is equal to 6. Clear? 3 plus I2 is equal to 6. Okay. I1 plus I2 is equal to 6. Okay. So I1 is equal to, it will be 2. I1 is equal to 2. So 2 plus I2 is equal to 6. So I2 is equal to 6 by 2 is equal to 3. Clear? So that means what? I1 is equal to 2 ampere. Okay. I2 is equal to what? 3 ampere. Okay, so that means what? Option number D. Option number D will be correct. Okay, 2 ampere and 3 ampere. Clear? So I am explaining it once again. So this is what? This is the triangle. Clear? So 6 ampere is entering at this point, and 2 current I1 and I2 ampere are existing from this point. So applying KCL at this point P, what you can write? 6 is 6 minus I1 minus I2 is equal to 0. That means I1 plus I2 is equal to 6. Clear? Now applying KVL, here it is what? Anti-clockwise, that's why minus 2I1. Here also the I1 current will flow because these and these will be in series. Clear? So minus 2I1. Here I2 current will flow. Clear? So plus 2I2 is equal to 0. So after calculating, I1 is coming 2 ampere, I2 is coming 3 ampere. So this option D will be correct. So the answer will be option D. Clear? 2 ampere, 3 ampere. Clear? So that will be the correct option. Clear? 2 ampere and 3 ampere. So hope you have understood this sum. Very easy. Only we have to apply the KCL and KVL. Clear? To solve this problem. So let us now, without further delay, move to problem number 2. Okay students, so let us now move to the second numeric problem of today's episode. Clear? So here the potential difference between A and B, the circuit is given. Clear? So the potential difference between A and B we have to find out. Okay? So see, so let me actually give a name here. It is C, it is D. Clear? So see, this 2 current is entering from here. Okay, so it is branching 2 part. Clear? One will come to this and this will be in series, and this and this will be in series. That means what? That means C A and AD resistors are in series. Clear? That means what? The equivalent resistance is equal to what? 2 plus 3 is equal to 5 ohms. Clear? Similarly, CB and BD are in series. So equivalent resistance is equal to what? 2 plus 3 is equal to 5 ohms. That means what? This and this, the resistance, equivalent resistance of this and this part is same. That means the 2 ampere will be splitted into 2 equal parts. Clear? As the resistances will, because the current will depend on the flow of current will depend on resistance, and resistance are same, that means it will be splitted, and these are parallel, so that means it will be splitted into 2 equal parts. That means what? That means if I again draw the circuit, clear? If I again draw the circuit, then it will come like this. It will become like 2 ohms, 3 ohms. Here it is 3 ohms, here it is 2 ohms. Clear? And here it is A, B, and it is what? C, it is D. It is 2 ampere. That means it is 1 ampere. It is also 1 ampere. It is 1 ampere. It is also 1 ampere. Clear? So 2 ampere current is splitted, 1 ampere upside and 1 ampere downside. Clear? Now the thing is that potential difference across CA. Okay, this across this resistor. So what we know? VC minus VA. Okay, VC minus VA. Clear? Is equal to what? What is the voltage? 2 into 1. Clear? Is equal to 2. It is equation number 1. Clear? And potential difference across what? CB. Across CB. Clear? Potential difference across CB. What we can write? VC minus VB is equal to VC minus VB means what? 3 into 1. Clear? 3 into 1 is equation number 2 is equal to 3. Okay? So 1 minus 2 we get what is 1? VC minus VA is equal to or we can write here, because the current is flowing from higher, yeah, Vc minus Va. Okay, so now Vc minus Va is equal to 2 and it is Vc minus Vb is equal to 3. Clear? So it is minus plus minus. Clear? So this will be cancelled. So Vb minus Va is equal to minus 1. So Va minus Vb is equal to 1. Clear? So Va minus Vb is nothing but the potential between the point A and B. That means what? 1 volt. Clear? So what is 1 volt? Option number A. So what will be the answer? The answer will be option number A. Clear? Option number A will be the answer. Clear? How much? 1 volt. Clear? So the voltage between A and B will be 1. Okay. So I am explaining it once again. Understand it properly. Okay. Very easy sum. It's not too hard. But you find that nothing is connected over here. How we can find out the potential difference between A and B? Clear? That question may arise. How to do? Because this is what? 5 ohms. This is also 5 ohms, the equivalent resistance. So the current will be split into 2 equal parts. Clear? That means 1 ampere, 1 ampere. 1 ampere upside, 1 ampere downside. 2 ampere current will be split into 2 equal parts. Why? Because the equivalent resistance of the upper and the lower part are same. Clear? Now the thing is that the voltage across this, it is what? Vc minus Va. We are finding what? I into R. Okay, I means 1 into R means 2. That means what? 2. Clear? 2 volt. If you want to write the unit. And this Vc minus Vb is equal to what? 3 into 1. 3. That means R means 3 and I means 1. That means 3 volt. Clear? So now subtracting these two, Vb minus Va is equal to minus 1. So Va minus Vb is equal to 1. So Va minus Vb means what? The potential difference between point A and B. It is coming 1 volt. Clear? So hope you have understood this. You can pause the video. Clear? You can copy the sum. Okay? And it's very important for the examination also. Clear? So now without further delay, let us move to the problem number 3. So here it is problem number 3. Okay, of today's episode. A circuit has a section ABC as shown in the figure. Its potential at point A, B, C are given. Clear? V1 and V2 and V3. That means what? It is V1. Clear? It is V1. It is V2. It is V3. Clear? Now the potential at point O. Okay, let it is VO. Clear? Or V0. Clear? We have to find out. This is unknown. We have to find out. So 4 options are given. V1 plus V2 plus V3. Okay, V1 by R1 plus V2 by R2 plus V3 by R3 into 1 by R1 plus 1 by R2 plus 1 by R3 whole to the minus 1. Clear? 0. V1 by R1 plus V2 by R2 plus V3 by R3 into R1 plus R2 plus R3. Clear? So different 4 options are given. Okay, 4 options are given. Now we have to find it. Okay, so this is the point. This is the point where, okay, where the I1, clear, it is I2 and it is I3. That is given. Clear? So where the I1, I2 and I3 are going out. Clear? So that means what? That means what we can write? Okay, for point O, applying KCL. What you can write? I1 minus I2 minus I3. All are going out. Clear? So is equal to what? 0. So that means what? I1 plus I2 plus I3 is equal to 0. It is equation number 1. Clear? Now what we can write? The potential of O is what? VO. So what we can write? VO minus V1. Okay, for OA. Clear? VO minus V1 is equal to what? I1 into R1. Clear? That means I1 is equal to what? VO minus V1 by R1. Clear? Similarly, I2 means this part. Okay, so it is what? VO minus V2. Clear? VO minus V2 by what? By R2. Clear? And I3 is equal to what you can write? Means this part. Clear? I3 VO minus V3 by R3. Clear? Now see I1, I2 and I3, three values we have got, and putting the value of I1, I2 and I3 in equation number 1. Clear? What is that? So I1 means what? V0 minus V1 by R1 plus V0 minus V2 by R2 plus V0 minus V3 by R3 is equal to what? Is equal to 0. Clear? So what we can write? V0 by R1, clear, plus V0 by R2 plus V0 by R3 minus V1 by R1 plus V2 by R2 plus V3 by R3 is equal to 0. Clear? Now what we can write? V0 by R1 plus V0 by R2 plus V0 by R3 is equal to what? V1 by R1 plus V2 by R2 plus V3 by R3. So V0 is common. 1 by R1 plus 1 by R2 plus 1 by R3 is equal to V1 by R1 plus V2 by R2 plus V3 by R3. Therefore, V0 is equal to V1 by R1 plus V2 by R2 plus V3 by R3 whole divided by 1 by R1 plus 1 by R2 plus 1 by R3. So what we can write? V0 is equal to V1 by R1 plus V2 by R2 plus V3 by R3 into 1 by R1 plus 1 by R2 plus 1 by R3 whole to the power minus 1. Why? Because it is division, so it will be whole to the power minus 1. So that is we have to find out the voltage at point O. So what is option number B? So the answer will be option number B. That is the option, correct option. Clear? So very easy sum, not too much hard, but the thing is that you have to keep calm and quiet. Clear? To solve this. For point O, applying what? 3 currents are going out. Clear? So minus I1 minus if it is going out, that means what? Not incoming, outgoing current. Outgoing current minus. So minus I1 minus I2 minus I3 is equal to 0. So I1 plus I2 plus I3 is equal to 0. It is equation number 1. We have to put the value of I1, I2, I3 in terms of V1, R1, V2, R2 and V3 and V0. Okay, like that. So here for this it is what? V0 current is going. So V0 minus V1 is equal to what? R1 into I1. Clear? So V0 minus V1 is equal to I1 into R1. So I1 is equal to what? This by this. So V0 minus V1 by R1. Clear up to this? Similarly I2. I2 means what? I2 means for this. It is what? V0 minus V2 by R2. Okay? And I3 is equal to V0 minus V3 by R3. Now we are putting the value of I1, I2 and I3 in equation number 1. So it is the value of I1, it is the value of I2, it is the value of I3. It is the value of I1, it is the value of I2, it is the value of I3. Clear? We are putting the value in equation number 1. This is the equation number 1 is equal to what? 0 is equal to 0. Clear? So now we are separating V0 by R1 minus V1 by R1 plus V0 by R2 minus V2 by R2 plus V0 by R3 minus V3 by R3. So V0 part we are getting together. So V0 by R1 plus here V0 by R2 plus here V0 by R3 minus common V1 by R1 plus it will be plus here because minus we have taken common V2 by R2 plus V3 by R3 is equal to 0. Clear? Now it is this minus this equal to 0. That means what? This part. Clear? So this part will be equal to this part that we have written, this part. Clear? Now it is V0 common. So 1 by R1 plus 1 by I2 plus 1 by R3 is equal to whatever whatever is there on right hand side we are writing that. Clear? So V0 is equal to what? This whole divided by this. So this whole divided by this. So if we want to shift it as numerator, then it will be minus whole to the power minus 1. So V1 by R1 plus V2 by R2 plus V3 by R3 into 1 by R1 plus 1 by R2 plus 1 by R3 whole to the power minus 1. So this option number B will be correct option. Clear? So hope you have understood this. Okay, it is not so much hard. Okay, only you have to apply the basic logic and basic knowledge. Okay, here only KCL, here no closed loop is there. KCL. Okay, there are some other formulas also, delta star, star delta conversion of the circuit, that we will learn later on. Okay, so only the basic concept, the KCL you have to apply and you can easily do this sum. Okay, so hope students you have understood this. Now let us move to the sum number 4. Okay students, so let us move to the today problem number or the question number 4. Clear? A battery and open switch. So open switch means the switch is open. See here, the open switch circuit is given. Clear? And a resistor. Okay, whatever the value of the resistor, that is connected in series. Series means one after another. Clear? This is the battery. Okay, that is positive number of cells are there. Okay, the positive terminal is the negative terminal, and resistor and the switch, these are connected in series. Okay, very good. Now consider the following 3 statements connecting the circuit. Okay, so 3 statements are given. Okay, what is the 3 statement? The voltmeter will read 0 if it is connected across points. If we connect the voltmeter, 3 points are given, P, Q and T. Clear? So when the voltmeter will give 0 reading. Okay, when it is connected P and T. Clear? P and T, P and Q and T. Clear? So which statements? These 3 which statements? Only statement 1 is correct, only statement 3 is correct, only 1 and 2 is correct. Clear? 1, 2 and 3 is correct. Okay, 1, 2 and 3 is correct. Clear? So which statement is correct? That we have to find out. Clear? Now this is a conceptual question. No need to do any numeric calculations over here. Okay, see, I am drawing the circuit once again. I am drawing the circuit once again. What is the circuit, so that you can understand it properly. So this is the battery. This is the battery. Clear? This is the resistance. Okay, and this is what? The open switch. The circuit is open. So the circuit is open. Clear? And this point, this is positive terminal, this is negative terminal. So this point is P, this point is Q, and this point is T. Clear? So this is actually the circuit is. So as the circuit is open, so no current will flow through the circuit. Circuit is open, it is not closed, so no current will flow. So if the voltmeter is connected between T, P and T, that means what? The current through this path, that will be what? 0. Clear? So P and T, if the potentiometer or the the voltmeter is connected between P and T, then what? No current, as the no current will flow, that means what? This through this path, as it is open circuit, that means it is 0. That means when the P and T, voltmeter is connected P and T, then what? It will give 0 reading. That means statement 1 is correct. Clear? Statement 2, P and Q. See, P and Q. P and Q means what? The battery, the 2 terminals of the battery. As no current is flowing to the outside or external circuit, but then what? It will show the voltage of the EMF of the battery. Clear? What will be the EMF? That will equal to the voltage. That means what? If the voltmeter is connected over here, okay, between P and Q, then what? Then it will show what? The EMF of battery. Clear? That means what? The voltage will not be 0. That means when the potential is connected across the battery P and Q, then the voltage will not be 0. Clear? And Q and T, when the voltmeter is connected Q and T, this part. Clear? Then this part also, as the circuit is closed, open, so this part also no current will flow. That means again the voltmeter reading will be 0. That means when it is connected to this path, clear, then it is 0. When it is connected to this part, then also it is 0. But when it is connected to P and Q, then it will show the EMF of the battery. The reading will not be 0. That means what? This. Okay. That means what? Only option 1 and option 3 is correct. Only option 1 and option 3 means when the voltmeter is connected to P and T and Q and T. P and T and Q and T. In that case, the reading of the voltmeter will be 0. That means only option 1 and option 3 is correct. So the answer will be what? Answer will be option 3. Clear? Option C. Only option 1 and option 3. Option 1 is P and T and option 3 is Q and T. When the voltmeter will be connected at these 2 points, then the reading of the voltmeter will be 0. But when the voltmeter will be connected across P and Q, then the reading cannot be 0. Why? Because it will show the EMF of the battery. Clear? The voltage will be equal to the EMF of the battery. Clear? So that is the logical question, but it's not hard, it's very easy. Clear? Open circuit, this part and this part will be 0, but this is the battery, this part will not be just 0. Clear? The voltmeter reading. Clear? So hope you have understood this. Clear? Now without further delay, let us move to the question number 5. Okay students, now let us move to the problem number 5. In the given figure, show the current in a part of an electric circuit. Then okay, let us say means what? 2 is incoming and 3 current outgoing. Very easy sum. Okay, so just don't be confused by watching this. Okay, 2 is incoming. So applying KCL. What? 2 is incoming, so 2 plus 2, and all others means what? 1 minus 1.3 minus I is equal to 0. Clear? So I is equal to what? So I is equal to 2 plus 2 minus 1 minus 1.3. Clear? So 4 minus 2.3 is equal to 1.7. Clear? So yes, 1.7. Clear? So the value of I will be what? Value of I is equal to 1.7 ampere. What is that 1.7? Option number A. So the answer will be what? Option number A. Clear? That will be the correct answer. Answer will be option number A. Clear? So that means what? Only we are applying the KCL. So incoming current 2 and 2, outgoing current 1, 1.3 and I. Clear? So 2 plus 2 minus 1 minus 1.3 minus I will be equal to 0. So I we are shifting, so I is equal to 4. Clear? And minus 1 minus 1.3 means what? Minus 2.3. So it will be 1.7. Clear? So option A will be the correct options. Clear? So very easy. Okay, you can do it very easily, I think. So let us now move to the problem number 6. Okay students, now let us move to the problem number or question number 6. Okay, so a 7-volt battery, it is the figure given. A 7-volt battery, okay, having internal resistance, having internal 7-volt battery with internal resistance 3 ohms. Clear? And 3-volt battery with internal resistance what? 1 ohm is connected. Okay, so as per the figure, so it is what? 10 ohm resistor is connected like this. Clear? So we have to find the current through 10 ohm resistor. We have to find the current, how much current is flowing to this resistor. Okay, clear? And the 7-volt battery, it will be 2 ohms. Clear? 2 ohms. Clear? Now the thing is that with the figure it will be 2 ohms. Now the thing is that I am redrawing the circuit. Why? Because I want to apply the KVL. Okay, how I am redrawing? See, 2 loops are there. This is what? Loop number, loop 1. This is loop 2. Clear? Now here what? A, B, C, D. Now for this, okay, let the main current I is flowing. Now here it will be divided. Here the current will be divided. Here the current will be divided into 2 parts. Clear? What? This is what? Suppose it is I1. So main current is I. So this part is I1. So this part will be what? I minus I1. Clear? So I1 current, then means we have to find out the value of actually I1. So I1 current will flow through 10 ohm resistor. Clear? Now I1 current will flow through this, and this I minus I1 will flow through this here. So it will again I minus I1 will flow, and again it will meet this I1 and I minus I1, and it will make I, and it will return back to this battery. Okay, so that will be the flow of current. So this is loop number 1, this is loop number 2. So 2 loops are there. So this is what? Always we have to take the closed loop. Okay, so from here A, D, P1, P2, A. So okay, or A, P2, P1, D, A. Okay, A, P2, P1, D, A. Clear? Closed loop. That means loop number 1 we are taking. Clear? So here it is what? Same direction current is flowing. Okay, clockwise direction. So 10 I1. Clear? Then it is what? Then again it is what? Same direction. So 2 into what? 2 into I. Clear? 2 into I. Then it is what? Then here it is what? It is 7 volt. Clear? So 7 volt. Clear? Minus 7 is equal to 0. Clear? So from this we are getting this one. Okay, this equation 10 I1 plus 2I is equal to 7. Now for this loop, okay, what is the loop? P2, B, C, P1, P2. P2, B, C, P1, P2. P2, P1, P2, P1, C, B, P2, whatever you can take. You can take this or you can take this, whatever, both are same, clear. So now it is what, minus 3, why? Because the current is flowing over here, okay, so minus 3, clear. So in the plus what, it is what, I minus I1, how much it is, I minus 1 ampere current is there, 1 is the resistance, clear, 1 is the resistance, okay. So 1 into I minus I1 minus 10 I1, okay, minus 10 I1, clear, is equal to why? Because the current is flowing like this, okay, but actually we are taking this like this, so minus 10 I1 is equal to 0, so I minus, okay, 11 I3 is equal to 3. Now from this, what we can write, from this, we have to actually find out the value of I, right? So here I is equal to what? 3 plus 11 I1. So from 1, what we get from 1? 10 I1 plus 2I is equal to 7. So 10 I1 plus 2 into I means what? 3 plus 11 I1 is equal to 7. Clear? So 10 I1 plus 6 plus 22 I1 is equal to 7. Okay. Now the thing is that 32 I1 is equal to what? Is equal to 7 minus 6. So I1 is equal to 1 by 32. Clear? So 1 by 32, right? So 0.0, okay, 396, okay, 4. So 10 is there. Clear? 10 is there. Okay. Then 1, 32, 8. So 0.031. That means what? Option number C. So answer will be what? Answer will be option number C. That will be your answer. Okay. So very easy. So two loops are there. Clear? So I current, here it will be split into two parts, I1 and I minus I1, and here again it is meeting and I returning back to the battery. Okay. So from this loop we are getting this, and from this loop we are getting this. Clear? And by putting the value of I in this equation equation number 1, clear, we are getting the value of I1. I1 we have to get, we have to find, because it is flowing through the 10 ohm resistor. I1 current is flowing to 10 ohm resistor. So it is coming 0.031. Okay, 0.031. Clear? So option number 3rd will be the correct option. So students, hope you have understood this problem also. Very easy. Now without further delay, let us move to the question number 7. Okay students, so that is one type of conceptual question. A principle of Wheatstone bridge is used, okay, to in an galvanometer or potentiometer, ammeter or voltmeter. The answer will be potentiometer. Clear? So when clear, so potentiometer, what is the P by Q is equal to R by X. Clear? So that is the in the balance condition. Clear? So the potential in potentiometer, the arms, the potentials will be balanced to have a null deflection, to get a null deflection. Clear? Inside the potentiometer, the potentials will be balanced to get a null deflection or to have a null deflection. That's why this property of Wheatstone bridge is used, okay, in potentiometer. Okay, the property of or the principle of Wheatstone bridge is used in potentiometer, not in galvanometer, not in ammeter, not in voltmeter. Ammeter is used to measure the current of a circuit. It is connected in series. Voltmeter is used to measure the voltage or potential difference of a circuit. It is used to measure the voltage of the circuit. Clear? But potentiometer, okay, the principle of Wheatstone bridge is used in potentiometer. So hope you have understood this. Clear? Now let us move to the problem number or the question number 8. Okay students, so now it is the last problem of today's episode, or last question of today's episode, last but not the least. Okay, so it's also conceptual. In a Wheatstone bridge, if the battery and the galvanometer are interchanged, that means in the position of the galvanometer the battery is placed, and the position of battery the galvanometer is placed. Okay, the deflection of the galvanometer will not change. Clear? They are interchanged. Clear? So the deflection of the both interchange in the position. So the deflection of the galvanometer what will not change, or it will it will remain same as before. Okay, it will remain same as before. Clear? So if we interchange the position of the galvanometer and the battery, then the deflection will not change, it will be same as before. So you have to remember this. Clear? So this type of conceptual questions also comes in the JEE or NEET examination. So students, hope you have understood today's all the problems and the questions which I have discussed, 8 number of questions. So you practice it at home. I have already uploaded many more questions from this topic. Clear? MCQ, current electricity. Clear? So hope you will get a huge advantage and benefit from all the episodes. And okay, and if I get I want to know what type of actually content you want to see. Okay, for your benefit. So write that in comments, and don't forget to subscribe my channel Physics Scholar Arka sir. Clear? So I need you beside me, and I am there to help you out in your academic careers. Okay, so without any hesitation, write in comment, share your problem, I will try to solve it. Clear? So up to this today, see you next. Thank you.